Hello everyone, my name is Hamza Karakush. I was working on a project which is line follower and I final up and today I tested it, it's working and I would like to share with you the PWM signal generator, the motor driver, how it is working and there is one more thing but I will tell you when I remember. Okay. It is the PID controlling. Okay, let's start. Firstly, let me share with you my other camera. I hope so you'll see, but um, okay, you can see right now. This robot, this is motor driver. There is 1, 2, 3, 4, 5, 6 total input. 2 of them is enable and the 4 of them is input and output. Yeah, it's also 4 of them is input. Actually 6 of them input, but the 2 of them enables RPVM signal taking and the motor in 1, motor in 2 takes the digital signal directly. It's 1 and 0. It determines where the motor turn is back or is forward. It's combination of inputs which gives to input 1 and input 2. Let's show how it is work. As you see, the qtr8rc is changing and detects to another place than white and black, and the valves is turning with respect to this changing. If it is black, in the middle side, it is okay. We can turn both. But if it is the corner, just one of them is turning to regulate this thing to middle side. Okay. And another things that I have to share with you is the PID algorithm. Right there, this is my whole algorithm. And firstly, I capture the values from sensors. This number is very important because you just use some of them. You don't have to 1,000 or 5,000 or another thousands numbers. Just get some and some evaluate your situation. If you take more, your delay will be increasing. And after all, I try to write square error, but it doesn't work. So I change it to in this algorithm. I will explain in another video. Yeah, in this PID section, I call the mean square error, which means the of my sensor error. For example, in here, sensor 4 is 0 and sensor 5 is 0. Both are 0. And so comes in if sensor 3 is not 0, this sensor error is 0. But if it is 0, return 1. If the sensor 2 is again 0, return 4. And sensor 1 is 0, our total sensor error which is returning is 16. It's like that. It's return a value to us in here. And we should calculate the PID. So I get the sensor values from here and it just returned one sensor value, one sensor error, and this sensor error will be equal to my proportional because it's just a proportional thing. So I just multiply this proportional value, just a coefficient, nothing more. And this is very critical point for my calculation because I used PID, not PD algorithm. There is something tricky. Let's pass this because I will define keep here, and after defining keep, I'll come back here and evaluate it. I is equal sensor error plus I, which means just increase sensor error with every calling PID function. When you call this function, if, by the way, we will multiply P times KP, I times KE. I give KE 0 here, but there is some error which we'll store it in the keep variable. It can be, say, it is the previous sensor error. Okay, we will keep it. And after all, we just compare keep and p-value. P-value is the new sensor error. If old sensor error is bigger than new sensor error, okay, you can make this I is 0. If keep value is old sensor value is less than and equal to new sensor error, yeah, that means there is nothing change. Just regulate ki 0.01. Okay, and this k1 ki will be 0.01 instead of 0. That means that fx is very amazing. I shocked after showing, you will shocked, I guess. Or kd times kd. What is kd? Kd is the derivative of the function. The sensor error minus old sensor error. This is new sensor. This is old sensor error. So it will give the difference of between these two things. If the error is the same, there will be 0. If sensor error, new sensor error is much higher than this keep one, this d will be much higher than, so PID values, my PID values is getting higher. That means I regulate here, PID here, PID, I define PID as a PID error variable, so I can use PID error here, and that means I have a threshold speed, because if I do not do this, my sensor error, when my sensor error is 0, it doesn't go anywhere. So I have to define some points to make this well is turning. Okay, after all, I define PID errors here. One of them is plus, one of them is minus. That means one well is turning, another doesn't turn. So we can regulate our qtr8rc sensor to the middle of this black line. So this is the whole code what I did. Let's see. It's a little bit, but let me show my I value to you. As you see, we have zero error here. No, it is zero error right here. But if I turn it here, listen the voice. Well is getting higher. It's the same for the other well too. Thank you for joining.